This is our introduction to organic chemistry. Now, organic chemistry, uh, it means the chemistry of compounds which contain the element carbon, right? And where the word organic came from originally was because people thought these molecules could only be made by living things. Now it's realized obviously they're not. They can be made artificially, but the name is stuck there. Now, carbon can form a vast number of compounds. Um, and most chemists who work as chemists are actually organic chemists. Very important branch of chemistry. Most of the useful compounds we have are actually carbon compounds. Right. And the reason why carbon can form so many compounds is because it tends to form four covalent bonds. Okay, if you think of hydrogen, that only forms one covalent bond. So we need to know about a group of chemicals called hydrocarbons, and they contain the elements carbon and hydrogen only. So carbon forms four bonds and hydrogen forms one. So the simplest hydrocarbon is actually like this. Carbon is forming four, and that's CH4 would be the formula there, and that is called methane, and that is gas that comes out of gas taps at school or comes out of the cooker at home. Right, so what carbon can do now, instead of forming a four bonds to hydrogen, it could form another bond to carbon there. And so now that carbon would need to form three other bonds to hydrogen. So you'd have a different molecule there, which would be C2H6. And then you could also get another one, get rid of that hydrogen and to another carbon instead. Okay, and you can see that that can go on. Right, now those this family of molecules are obviously quite similar to each other. Hydrocarbons with carbon and hydrogen only, these are called alkanes. And here are the first five alkanes. So, incidentally, you will come across another group of another family of molecules called the alkenes, and they consist of hydrogen and carbon only. But the difference is alkenes don't just contain single bonds, they can contain some double bonds between carbons as well. And that gives them similar but different properties. Right, let's have a look at the alkanes then, this family here. So the first one is methane, which is CH4. The next one, ethane, which I drew, is C2H4. Then it's propane, then butane, and then pentane. And if you want to know the numbers of the other ones, it's look at the number of carbons, and it's like your math shape. So it's hexane, 7 would be heptane, 8 octane, 9 nonane, and so on. But you only need to know up to butane. So if you look at those formulas there, you can come up with something called a general formula, which is pretty useful. The general formula for alkanes is Cn. So if you have n carbon atoms, you're going to need double the number of hydrogens and plus two more. So it's H2n plus 2. And if you look at like pentane down there, you can see that each carbon has two hydrogen atoms. So that's why it's 2H2n. But then you've also got these ones on the end, and that's why it's H2n plus 2. Okay, so that's the general formula of alkanes. So if you wanted to say what would be the formula of a compound which has got 18 hydrogens, so it's 18 carbons, sorry, it'd be C18, H2 times 18 is 36, plus 2 makes 38. That would be the formula of that one. And right, let's just talk a little bit about crude oil here. So crude oil is a mixture of hydrocarbons, which are mostly alkanes. And they range in size. They're just, the only difference is they've all got different sizes. So the smallest one would be methane. And they range up to ones which are about 50 carbons long. Okay, and everything else in between. Right, so let's have a look at the boiling points of these alkanes as they get bigger. You can see methane is a gas at room temperature, minus 164, very low boiling point. Ethane, a little bit higher, minus 89. Propane, minus 42. By the time you get to butane, it's about 0. So on a very cold day, butane would be a liquid, but usually it's a gas. And then by the time you get to pentane, that is definitely a liquid at room temperature. Incidentally, when you get to molecules which are about 7 carbons long up to about maybe 10 carbons long, that is basically what petrol is, that you put in a petrol car. Diesel, that's when you've got longer molecules there. And then when you get up to like 50 carbons long, that would be a substance called, ones which are very long, it's a mixture of long ones. It's called bitumen, which is that black bitumen, which is the black tar that is put on roads and put on roofs as waterproofing and so on. Right. Now, all of the alkanes are all good fuels. They're all fuels. Now, what that means is, with a fuel, is when you burn it, you get a lot of energy released. Okay, so let's look at what happens when you burn methane. So you've got methane, and of course, to burn anything, you need oxygen. Now, if you stick oxygen onto the carbons, you're going to get CO2. And if you stick the oxygen onto the hydrogens in there, you will get H2O, which will be, so when you burn methane, you get carbon dioxide and you get water. It's because it's hot, it'll be water vapor. And a common mistake is that people think you get hydrogen there. You'd never get hydrogen, because hydrogen is a really flammable gas. When you burn methane, you go for flame, so it would burn and form water. It would never stay as hydrogen. So remember that. Right, so let's try and balance that equation. Well, we've got a 1 carbon on the left, 1 carbon on the right, so that's fine. We've got 4 hydrogens there, and we need 2 there. So we need to put a 2 in front of the water, and then we need to balance for the oxygen. So we've got 2 oxygens in the carbon dioxide and 2 in the water. So we need 4 oxygens. So we need to put a big 2 there. Let's do another one. Let's do C3H8. And you're going to add oxygen to that. Again, the products are going to be carbon dioxide and water. In that case, you have got 3 carbons there. So we need to form 3 carbon dioxides. And we've got 8 hydrogens there. So we are going to, and only 2 there. So we need to form 4 waters. Then we need to add up, well, we've got 6 oxygens in the carbon dioxide and 4 in the water makes 10. So we need a 5 in front of the O2. Okay, so you'll notice the alkanes which have got even numbers of carbons are a bit trickier to balance, but I'll let you do them by yourself. Okay, so alkanes, crude oil is a mixture of alkanes. They're all good fuels. You get a lot of energy out when you burn them, and that's what we use crude oil for mostly, as a source of fuels. But before we can use it, you see the next video, you've got to separate it, because you can't, you probably know, a petrol engine, you can't put diesel into a petrol car, it will spoil the engine. The molecules in petrol all need to be about the same number of carbons long. Same in diesel, you've got another one where the number of carbons are slightly longer, and so on. And we'll talk about that in the next video, how you separate crude oil, which you do that by using fractional distillation.